All right, in this lesson we're going to solve exponential and logarithmic equations. It says part 1 and part 2 because that's how I taught it, but I'm going to record all of it in one video, right? So the first half of this video is going to be on exponential equations and the other half is going to be on logarithmic equations. Now we've already solved some exponential equations before. You see under here where it says core concepts, property of equality for exponential equations. This is kind of like our one-to-one property that we discussed in a previous section, right? So if you had something like 2 to the x equals 8, right? How would we do that? Well, we would change 8 to have a base of 2, and it would be something like 2 to the x equals 2 to the third, right? And because our bases are the same, then our exponents need to be the same as well. So essentially what we do is cross out our bases, and then you set our exponents equal to each other. So I get x equals 3. All right. But let's say I had something like 2 to the x equals, 10. All right. There's no way to get 10 to have a base of 2. All right. So we're going to need to solve this a different way. Now, what you see in this little paragraph right here, this last sentence right here, is how we're going to solve these kinds of problems. Now, if you look at this first example, this looks like something that we've done before, right? Because if you have done enough of these problems, you should be able to recognize that 100 and 1 over 10 can be rewritten to have the same base. Now, 100, I know that that's 10 squared. So I have 10 squared to the x. 1 over 10 is the same as 10 to the negative 1, right? So if you remember the fraction, we can rewrite using an exponent. Right, so we get 10 to the negative 1 to the x minus 3. And now we have the same base. All we need to do is use power to a power to simplify, clean it up a bit, and then we can go ahead and cancel our bases. So we get 10 to the 2x equals 10 to the negative x plus 3. And then because they have the same base, just cancel out the bases, and then you get 2x equals negative x plus 3. And then just solve this equation. We add x everywhere. And then we end up with 3x equals 3. And then divide 3 everywhere. And so we get x equals 1. All right. So pretty basic example, something that you guys have seen before. Something that you haven't seen before is something like part B. We have 2 to the x equals 7. Now there's no way to rewrite 7 to have a base of 2. So what we're going to do instead is we're going to use logarithms, our property of logarithms, to kind of get that exponent out of there, right? Because our issue right here is that x, right? I don't know what I need to raise 2 to get 7, right? So what we're going to do is we're going to use logarithms. So what you can do in the strategy for doing these kinds of problems when you can't get the same base, I would just go ahead and log both sides. So I would take the log of 2 to the x equals log of 7, right? So all I did was I put each side of the equation inside of a log. All right, that's all you do here. And now what you can do is you can use a property of logarithms to get that exponent to the front. If you remember, any exponent inside of a logarithm can be written out front. So this becomes x times log of 2 equals log of 7. Whoa, hang on. Okay, equals log of 7. All right, so if you plug in log of 2 into your calculator, you will get a number, right? So this right here, all right, let me get it. This right here, this is a number, right? If you put log 2 in your calculator, you will get a number. So what you can do is you can divide both sides by log 2. Right, divide by log 2 everywhere, right, on both sides. And then what that's going to do is that's going to cancel out this log 2, and so you get x equals log 7 over log 2. All right, and then this is your exact answer. Now, a lot of times we're going to ask you to rewrite as a decimal rounded to, some decimal places. We'll be a little more specific in the directions of how many decimal places we want you to round, right? So here we don't tell you to round. So this would be your exact answer, but your decimal approximation is going to be about, if you put this in your calculator, you're going to get about 807, right? So around to 3 decimal places. All right, so this is your decimal approximation. Okay, so let's do a couple more like that. So this first one, I have 2 to the x equals 5. Now, again, I don't know what I need to raise 2 to the power of to get 5. And that's not going to be a nice clean number, right? Because I know 2 to the second power is going to get you 4, right? So I know 2 squared, that's 4, and I know 2 to the third is 8, right? So the jump from 2 to 3, that's just 1 digit above, right? But we know that 5 is going to be between 4 and 8, right? So make a note that your answer should be between 2 and 3, right? So 2 to some power between 2 and 3 is going to get you 5. Now to find out exactly what that's going to be, again, I'm going to log both sides. Now, note that you don't have to just use log, right? You can use ln. It's going to be the exact same thing, right? So in this case, I'm going to try ln. I'm going to take the natural log of both sides. So I get ln to the 2x equals ln of 5. Now remember, ln is just another logarithm, right? It's log base e. So I get 2 to the x. I can take this exponent. Again, it's a logarithm, so you can use your properties. I get x times ln of 2 equals ln of 5. So then what we can do is we can now divide both sides by ln of 2. Because again, ln of 2 is a number, right? If you put that in your calculator, you will get some strange decimal answer. So I get my exact answer is going to be ln of 5 over ln of 2. All right? Now, your decimal approximation, just go ahead and plug this in your calculator. All right, so let me give that a try. So ln of 5 divided by ln of 2 is going to get you about 2.322. Right, I'm going to say to 3 decimal places is fine. All right. Now, if you tried it with log, right, so if you decided to do what we did in the previous page and did log of both sides, you would get the exact same answer. All right, so it doesn't matter which one you do. All right, so hopefully that's clear. Let's do the next one as well. All right, so I have 7 to the 9x equals 15. Once again, I can't change 15 to have a base of 7. So what I'm going to do is I'm going to log both sides. Now again, it doesn't matter if you do log or ln. So I'm going to log both sides. And then I'm going to take this 9x and I'm going to bring it out front. Right? That's a property of our exponent. So I get 9x times log 7 equals log 15. And now I want the x by itself, so I'm going to go ahead and divide. I don't want to just divide log 7, though, because I also have a 9 in front. You could do it in 2 steps if you wanted, but just to make it a little bit faster, let's do everything in 1 step. If I have 2 things that are multiplying this x, then you can just divide everything by that, by whatever's being multiplied. Right? So I can divide both sides by 9 log 7. All right? And then 9s are going to cancel. Log 7s are going to cancel. So then I get x is log 15 over 9 log 7. All right, and this is our exact answer. Now, our decimal approximation, just plug this entire thing in your calculator. Be mindful of parentheses, right? Because if you're somebody who would just type it in exactly as you see it, you might risk getting a wrong answer from your calculator. Just because a lot of you might do log 15 divided by 9 log 7, right? But make sure this 9 log 7 is in parentheses. Otherwise, your calculator is going to do order of operations, and it's not going to read that log 7 as in the denominator, right? So just something to be mindful of. All right, so I'm going to go ahead and type this into my calculator, and then we should get our decimal approximation is going to be about 0.155, right, to 3 decimal places. All right, good. And now the next one, it looks a little bit more complicated, but it's the same idea, right? I want to make sure first, though, that my exponential expression is by itself. Now, if you notice here, the only thing that is a base in this entire equation is this e, right? E is the only base here. That means I want to get rid of 4 and I want to get rid of this minus 7. So to do that, I would just do inverse operations. So treat it as if it was an equation, like 4x minus 7 equals 13. Now, how do you get x by itself? Well, you would, of course, do inverse operations, right? You would add 7 and then divide by 4. That's exactly what we're going to do here, because this time I want e to the negative 0.3x by itself. So I'm going to add 7, and then I get 4 e to the negative 0.3x equals 20. And then now I can divide by 4. So then I get e to the negative 0.3x equals 5. And then this time you can log or ln. I would ln this one, right? If you want to know why, right? Think about it. If you ln this side and the other side, right? So here, what happens to ln and e? If you remember from the previous section, ln and e are going to cancel out. So then you're only left with negative 0.3x equals ln of 5. All right, so then we can go ahead and divide both sides by negative 0.3. And then we get x equals negative ln of 5 over 0.3. All right, now this is our exact answer. So now let's put this into our calculator. Let's see what we get as our decimal approximation. All right, so if you put this in your calculator, we should get about negative 5.365. All right. All right, now that's a strategy for solving any kind of log equation, right? So it kind of builds on what we did before, and it ties everything together, right? So that's how exponents and logs are kind of, because they undo each other, we can use it when we want to solve exponential equations and vice versa. And then you're going to see in the rest of this lesson that we're going to do the same thing with logarithms, right? So we're going to use properties of logarithms to solve logarithmic equations, and then you're going to see that really in the end we're just trying to convert it to an exponential equation. All right, so like I was just saying, we've done logarithmic equations before, right? We've used one-to-one property, and then we've also had some cases where we can just convert it to an exponential equation, but sometimes you get problems that are a little bit more complicated than that. So we're going to do some of those examples now. Now, these first two are things that we've seen before, right? So in our previous lesson, I've showed you guys how to do some equations like these, right? So if you look at the first one, I have ln of 4x minus 7 equals ln of x plus 5. All you have to do is use your one-to-one property and notice that both sides have an ln. So I can go ahead and cancel them out, and then you're just going to set equal whatever's on the inside. All right, and then this is just a linear equation that we want to solve. So I'm going to go ahead and subtract x on both sides, and then you can add 7 on both sides, and so we get 3x equals 12, divide both sides by 3, and so you get x equals 4. All right, super easy, something we've done before. And then the next one, similar story, right? So I have log base 2 of 5x minus 17 equals 3. What we can do is we can convert it to an exponential, right? I only see one log and it equals a number. So I'm going to convert it. And then remember that this is the same as 2 to the third power equals 5x minus 17. And then 2 to the third power is 8. So I get 8 is 5x minus 17. And I can add 17 on both sides. I get 25 is 5x. Divide both sides by 5, and so I get x equals 5. Now it gets a little bit different when you have something like this. I have log 2x plus log x minus 5 equals 2. Now before we had a log equals a log, or I had a log equals a number. We haven't really had a log plus a log equals a number. But if you remember from the previous lesson, right, so 5.3, this plus between the logs counts as a multiplication inside the logs. So what I can do is I could do log of 2x times x minus 5. And this is equal to 2. And now notice now we can simplify the inside a bit. So we get log of 2x squared minus 10x equals 2. And then if we recall, if you don't see a base, you assume that the base is 10. So this is log base 10. And then we can just convert this to exponential, right? Now this looks like something that we've done before. So we get 2x squared minus 10x equals 10 squared. And now 10 squared is 100, so I get 2x squared minus 10x equals 100. And then this is just a quadratic equation, so I can go ahead and subtract 100 on both sides, and then we get 2x squared minus 10x minus 100 equals 0. And if we recall, to solve a quadratic equation, first we want to take out a GCF and then see if whatever's left over is factorable. In this case, we can divide everything by 2. Right, divide both sides of our equation by 2, and then we get x squared minus 5x minus 50 equals 0. And then we need factors of negative 50 that add to negative 5. That's going to get us negative 10 and positive 5. All right, so then we get two answers, x equals 10 and x equals negative 5. Now, we aren't done here. We actually need to check. Right, we actually need to check our answers, because if we recall, right, and we didn't cover it in so much depth, but you can't have a negative inside of your log, right? If you try to type in log of something negative and you can try it in your calculator, you're going to get no solution, or you're going to see like something that says undefined. You might see domain error, right? But regardless, you're not going to get an answer, right? So to check, I would plug in each of our answers into our original and see if we get anything negative. Now, it doesn't have to be a rigorous check. All we have to do is make sure that we don't get anything negative. So I get log of 2 times 10 plus log of 10 minus 5 equals 2. Now, 2 times 10 is 20. That's positive. 10 minus 5 is 5. That's also positive. So this works. All right? That's all we really have to do. You can go all the way if you want to, but really, if it's positive, we know it's going to work because we got that as an answer. Now, if you try negative 5, we get log of 2 times negative 5. And if you notice, we can even stop right here, right? Because this is going to get us a negative 10, and log of negative 10 is no solution. So I know negative 5 isn't going to work. If you didn't get that, if you're not sure what I'm talking about, I'm going to keep going. We get log of negative 5 minus 5 equals 2. And then you try to simplify these fully. And then still we end up with the same thing, right? It doesn't really matter if it's one and not the other, right? If it's both, right? As long as there's a negative, it's not going to work. And because we have a negative inside of our log, that is not allowed. So our only answer here is 10, right? That's the only little difference between these kinds of quadratic equations and ones that you've done before, is you want to check, plug in your answer and make sure that it works. All right, so let's try these last 4 problems. Number 5. This one's a pretty simple one. All you have to do is check that ln is the same on both sides, and then you can just go ahead and cancel out your ln's. Right? So I'll make a note right here, 5. We canceled out our ln's, and then we're left with 7x minus 4 equals 2x plus 11. And then you're left with 5x equals 15, and then you just get x is 3. In this case, you don't have to check, and if you do check, you'd notice that you get positive inside of your logs, right? So it works. All right, the next one, 6. We have a log equals a number, so all we have to do is get it in exponential form. All right, so I get 2 to the 5th power equals x minus 6, and 2 to the 5th power is going to get you 32 equals x minus 6, and then you get a simple equation, so you get x equals 38. And once again, if you plug this back in, you're going to get a positive inside of your log, so we know that it works. All right, the next one is something a little bit newer. Right, so this is one where you have to use properties. So I get log of 5x plus log of x minus 1 equals 2. And because these logs are separated by a plus, all right, that means we're going to multiply inside of our logs. So I get log of 5x times x minus 1 equals 2. And then you can clean it up inside. So we get log of 5x squared minus 5x equals 2. Remember, if you don't see a log, that's log base 10. Right? So because we now have a base, we can convert it to exponential. So we get 5x squared minus 5x equals 10 squared. And we had established before that 10 squared is 100. Right? And this is just a quadratic equation. So we can get 100 to the other side. Right? It looks very similar to something that we did before. All right, and like before, we can take out a GCF here. We can divide everything by 5. And then we get x squared minus x minus 20 equals 0. So we need factors of negative 20 that add to negative 1. That's going to get us a negative 5 and a positive 4. All right, so our answers are going to be x is 5 and x is negative 4. Once again, with logs, you need to check and make sure that you don't get a negative inside of your log. If you plug in positive 5, then you see that we get a positive inside of our logs. But if you plug in a negative 4, 5 times negative 4 gets you negative 20. And negative 4 minus 1 gets you a negative 5. We cannot have a negative inside of our logs, so I know that negative 4 is not a solution. The only solution here is x equals 5. All right, let's try the same thing with the last one. All right, this is another one that we can condense. All right, so let me rewrite the problem. Now, once again, I have a plus between my logs. That means I'm going to multiply. So I get log base 4 of x times x plus 12 equals 3. And then x times x plus 12, I can distribute that x. So we get log base 4 of x squared plus 12x equals 3. And now once again, you can convert it to exponential. All right, so 4 is your base, so I'm going to raise 4 to the third power. So I get x squared plus 12x equals 4 to the third power. And 4 to the third power is going to get you 64. All right, so once again, we're left with a quadratic equation. So make sure that it's set equal to 0. And see if we can factor it. So this one we have x squared plus 12x minus 64 equals 0. And factors of negative 64 that add to positive 12 are going to get you a positive 16 and a negative 4. So that means our two answers here are going to be negative 16 and positive 4. But once again, you need to check. If I plug in a negative 16 here, I got negative 16 plus 12. That gets you a negative 4. And even right here, we only have an x. So if you plug in negative 16 for x, we get log base 4 negative 16. That's not going to work. Our only solution here is going to be 4. If you plug in 4 into your original equation, then we don't have any negatives inside of our log, so our only answer here is 4. All right, that's how you tackle these kinds of problems. That's the only thing that's really new. Just make sure you know your properties.